Question number 41. The correct statement regarding addition of sodium hydrogen sulfide to a carbonyl compound is. So we know that sodium hydrogen sulfide is NaHSO3. Okay. So the first option, attack happens by negative charge on oxygen. If you look at the structure of HSO3 minus, we have this structure. So if we compare the negative charge over oxygen, which is delocalized, and the lone pairs over sulfur, which are generally more nucleophilic in nature, so the attack happens via the lone pairs over sulfur. Okay. So statement 1 is incorrect. If you look at the second option now, the rate of addition is always greater for ketones than aldehydes. Student, this statement is incorrect. If we have a ketone, let's say acetone, and if we compare it to an aldehyde, let's say acetaldehyde, we know that the aldehyde is more reactive towards nucleophilic attack as there is less hindrance, and the delta positive on this carbon is greater than the delta positive present over here, which is lessened due to the inductive effect of two methyl groups attached. So this is less available for attack than this. So the reaction rate will be much greater for aldehydes than for ketones. So statement 2 is incorrect. Let us look at the third option now. Bisulfite addition product cannot be hydrolyzed in basic medium. This is incorrect. The bisulfite addition product can be hydrolyzed in both the mediums. So both H plus H2O or OH minus H2O are going to regenerate the carbonyl compound and free it of the bisulfite which was added to it. Okay. So it must automatically mean that the fourth statement is correct. So it can be used as a method to purify and separate aldehyde. Yes, this statement is correct. It has a specific preference for aldehydes and it forms a precipitate on reaction with most of the aldehydes and separate them from a solution. Hence, it can be purified and separated from a mixture of compounds. So students, we have to mark option 4 as the correct answer to our question. Let us look at the next question now. Question 42. An organic compound has only CHNO and compound A gives red solid on reaction with 2,4-DNP. It means that it must be an aldehyde or a ketone. A react with OH minus in heat. This is the aldol reagent to give B as one of the product. So we have been given B and we have to reverse engineer the mechanism and figure out the compound A. So students, we know that during aldol condensation in the last step, after the formation of aldol, we have elimination. So a beta hydroxy aldehyde or ketone, it undergoes dehydration to form an alpha beta unsaturated carbonyl compound. So we have the alpha beta unsaturated compound over here. So this must be the alpha position, this must be the beta position. So the alpha beta unsaturated compound must have been formed via the beta hydroxy carbonyl compound. So we have the beta hydroxy structure. And if we again reverse engineer the mechanism, we can see that this bond must have been formed because of the attack of nucleophile. So negative charge created here should have attacked this carbonyl compound. Okay. So this is the conjugate base created by the substrate A. So if we look at the structure of A, it is going to look something like this. Okay. So we have a aldehyde and we have a methyl ketone separated by 5 carbons. So we have a methyl ketone, then we have 5 carbon atoms, and then we have a aldehyde. So looking at the options, we can see that the correct structure of A is given in option 1, which is the answer to our question. Let us look at the next question. Question 43. P is a disaccharide. Hydrolysis of the disaccharide gives 2 monosaccharides RNS. So students, if we look at the structure given to us, so this structure is an alpha glucopyranose or is an alpha glucose. And if you look at this structure, this is a beta fructose or a beta fructofuranose. Okay. And if we try and label the carbons, so this will be the carbon number 1 of glucose, and whereas this will be the carbon number 2 of fructose. Okay. So this is sucrose, and the monosaccharides RN as mentioned in the question are glucose and fructose. Okay. Let us now consider the given statements. P is non-reducing and formed by C1C2 glycosidic linkage of alpha D glucose and alpha D fructose. Students, this statement is incorrect as the fructose formed here is not alpha D, it is beta D fructose. Okay. Let us look at the second option now. P is dextrorotatory, but after hydrolysis, the solution becomes levorotatory. Students, this statement is also correct. We know that sucrose is dextro compound. Upon hydrolysis, it gives an equimolar mixture of glucose and fructose. And the rotation of glucose is positive 52.5 degree, whereas the specific rotation of fructose is minus 92.4. So eventually in an equimolar mixture, the rotation of fructose is going to dominate and the solution will be levorotatory. So this statement is correct. If you look at statement 3 now, both R and S are reducing sugars. Students, we know that both glucose and fructose are reducing sugars in fact. So this statement is also correct. Both R and S form the same osazone. Students, osazone is formed on reaction with phenylhydrazine. So we have PH, NH, NH2. On reaction with both glucose and fructose, it is going to form the same osazone as they both form the same enediol. Okay, so the same enediol is going to lead to the formation of the same osazone in both the case. So students, S1 is incorrect, whereas statement 2, 3 and 4 are correct. So we have to mark incorrect statements for this question. So we have to mark the option 1 as the correct answer to our question. Let us look at the next question now. Question number 44. We have to select the incorrect statement about carbene. Carbene is a neutral species. Yes, students. We know carbene has this formula and it is a neutral species. Carbon retains its 4 electrons. Dichlorocarbene can be formed in Riemann-Tiemann reaction. This statement is also correct, students. Dichlorocarbene is CCl2 and this is formed when CHCl3 is allowed to react in presence of a strong base, OH-. So alpha elimination takes place. And dichlorocarbene is generated. Okay. So this is also correct. The first statement was also correct. Carbene can insert into both sigma and pi bonds. Students, this statement is also correct. We have the formation of cyclopropane due to insertion of carbene to an alkene. The alkene may be branched or not. So we can keep the valencies open. And this just inserts into this pi bond to give us cyclopropane derivative. We are not again labeling the hydrogens. Okay. And it can also insert into sigma bonds. Here we had seen the case of insertion into pi bonds. It can also insert into sigma bonds. We can have alcohols reacting with carbene. And these alcohols, they form methyl ethers. We can also have carboxylic acids reacting with carbene to give us methyl esters. Okay. So in these cases, the carbene inserts into a sigma bond and in this case it inserts into a pi bond. So statement 3 is also correct, students. Let us look at statement 4 now. Carbene is generated from amines on reaction with nitrous acid. This statement is incorrect, students. On reaction of amines with nitrous acid, diazo compounds are formed and not carbene. So we have to select the incorrect statement and we have to mark option 4 as the correct answer to our question. Let us look at question number 45 now. An acid on reaction with alcohol forms esters. This reaction is called as esterification. Esterification may be intermolecular or intramolecular. Select the compound which will not show esterification reaction with H plus heat. So students, we have 4 different hydroxy acids. So in the first one we have alpha, in the second one we have beta, and the third and fourth we have gamma hydroxy and delta hydroxy respectively. Okay. So we know that on esterification, the alpha hydroxy acid, it undergoes intermolecular esterification to form a cyclic diester. We know that beta hydroxy acid on reaction with H plus heat is going to form alpha beta unsaturated acid. So we are going to have CH3, CH2, CH double bond CH and COH. It is not going to form an ester in this case. If we look at the gamma and the delta hydroxy acids, these undergo intramolecular esterification to give cyclic esters. Okay. The gamma will form a 5-membered ester, whereas the delta form is going to form a 6-membered ester. Okay. So if we look at the question asked to us, that which compound will not show esterification reaction, so we can see that the option 2 has to be marked as the correct answer for this question. Let us look at the next question.